We're asked to classify the reaction and then balance the equation. This is a combustion reaction because we have a hydrocarbon and we have oxygen as part of the reactants. So I'm going to rewrite this so I have a little bit more space. And in a complete combustion, the products are going to be carbon dioxide gas and water vapor. Let's balance this equation. I'm going to separate the products from the reactants. I have 3 carbons on the reactant side. I have 6 hydrogens and 2 oxygens. Over to the product side, I have 1 carbon, 2 hydrogens, and oxygen appears in 2 different locations. So there's 2 in carbon dioxide and there's 1 in the water. Now, the first thing I'm going to do is, well, generally you want to balance the oxygens last because they appear in multiple locations. But I noticed on the right side I have an odd number. And on the reactant side, I can only have multiples of even numbers. So I'm going to try to first turn this oxygen into an even number. And that oxygen is connected to the hydrogen. All right. So I'm going to balance the hydrogen first. And hopefully that'll turn this into an even number. I'm going to multiply where I see the hydrogen on the product side by 3. By putting a 3 in the coefficient. Now that's also going to multiply the oxygen connected to that water by 3. Now I still have an odd number. So what I'm going to do now is just double that number. So instead of multiplying by 3, I'm going to multiply by 6. And the reason I did that is, again, I need this side to be an even number of oxygens. Alright, so now I'm going to go to the left side and balance out the hydrogens. Now I also need to update every other element in that compound. So now I can go back to the product side, balance out the carbons. But I also need to update the oxygen. That's this one. So you got to keep track of which line refers to which oxygen. Alright, so now I've got the carbons and the hydrogen balanced. I can do this oxygen last, and I have even numbers. So I have a total of 18 oxygens on the product side, and on the reactant side, 2 times 9 will give us 18. So that multiplier goes as the coefficient where I see oxygen. So there's your balance equation for this combustion reaction.